Okay, so here's what you really need to know about what I have said so far. Uh, if you have two new coordinates u and v that you use to think of x as a function of u and v and y as a function of u and v, then you can find the Jacobian of u and v just to be the absolute value of the determinant of xu, yu, xv, yv. By that I mean, again, x and u can be, x and y can be written as functions of u and v, and then you take the partial derivatives of x and y with respect to u, you put that in the first row, and then you take the partial derivatives of x and y with respect to v, and you put that in the second row. It's also okay if you had written them as a column. That's also fine. So the formula that you need to know is that the Jacobian is essentially, and this is the key formula, but I think it's easier just to remember it from this perspective, but it's up to you. So this is the Jacobian, and say you want to integrate a function. So if you want to integrate say you're given a function of two variables x and y, and you are integrating that in some region R, in R being here some region in the xy plane. If you want to use this idea of changing coordinates, what you have to do is rewrite f as a function of u and v, so the integrand, since you have x and y as functions of u and v, you can do the corresponding substitutions and you'll think of f as a function of u and v. And then let's say you put here this is the a, you should think of it as being dy dx or dx dy. And then you have to find the bounds of the region in terms of u and v. In terms of u and v. And then the integral, this integral becomes, let's call it asterisk, this integral becomes, well, it's still over R, but with the new bounds, or with the change bounds. You'll see in the examples what I mean by this. And then f has been substituted, so now it's still the same f, but you have re-expressed it as a function of u and v, so let's just write it this way. Well, then what I mean by this notation is you should think that you re-express f as a function of u and v. And the a, the whole point of the a is that the a gets changed. dy dx or dx dy, it does not become just du dv. It gets multiplied by the Jacobian. That's the whole point of what we have been discussing, because that's like how we computed the element of area before. So You can like by this I just mean that you can write dv du or du dv in the same way in which you could write dy dx or dx dy. So again, the next example that the next video that I will do is just a bunch of I will do 2 examples about how this is supposed to work, so that this becomes more clear.